You're standing outside at noon, and the sun simply vanishes. Not sets, not gets eclipsed by the moon, not fades behind clouds. Gone, completely, instantly, as if switched off. Here's the part almost nobody gets right. You wouldn't notice for another 8 minutes and 20 seconds. And when you finally did, the sky wouldn't even be the first thing that changed. That's the real answer to today's question. What if the sun disappeared right now? Not burned out slowly over billions of years, the way it eventually will, once it exhausts its nuclear fuel. An instant disappearance, this second, no warning. And the true sequence of events depends on something most people never think about. Gravity and light don't travel instantly across space, they both have the exact same speed limit. This isn't just a fun hypothetical. The sun holds our entire solar system together through gravity, and everything from Earth's seasons to ocean tides depends on a star that, from our perspective, we're always seeing 8 minutes and 20 seconds in the past. Every photograph of the sun, every sunrise you've ever watched, is already old news by the time it reaches your eyes. Astronomers actually rely on this delay constantly, using it to time signals from spacecraft and to double-check the distances between planets with extraordinary precision, treating the 8-minute lag as a built-in feature of the universe rather than an inconvenience. Removing the sun doesn't just take away light. It takes away the invisible leash holding our entire planet in orbit. Here's the one concept you need. Both light and gravity travel at the same universal speed limit, the speed of light itself, roughly 186,000 miles per second. This wasn't obvious for most of scientific history. Isaac Newton assumed gravity acted instantly across any distance, and it took Einstein's general relativity, published in 1915, to establish that gravitational effects propagate at exactly the same speed as light. The sun is about 93 million miles away, which means both its light and its gravitational pull take that same 8 minutes and 20 seconds to cross the gap and reach Earth. If the sun vanished right now, Earth wouldn't know it happened, gravitationally or visually, until that exact amount of time had passed. So let's walk through what actually happens, stage by stage. First, for those full 8 minutes and 20 seconds, absolutely nothing appears different. The sky stays blue, sunlight keeps warming your skin, and Earth keeps orbiting normally, still gravitationally locked to a star that, unknown to anyone, no longer exists. Anyone watching wouldn't have any instrument on Earth capable of detecting the loss until that delay finally ran out. Then, at the 8-minute 20-second mark, everything changes simultaneously. The sky goes instantly black, daylight or not, anywhere on Earth facing what used to be the sun. At the exact same moment, Earth's orbit stops being a curve and becomes a straight line, since the gravitational pull holding us in that curved path has vanished at the same instant the light did. Earth goes flying off into the darkness of interstellar space, in whatever direction it happened to be moving at that exact second, at roughly 67,000 miles per hour, the same speed we'd already been orbiting at. The moon, still gravitationally bound to Earth, would come along for the ride, continuing to circle us even as both worlds drift together into permanent darkness. Within the first day, temperatures begin falling, but slower than most people expect. Earth's oceans and atmosphere store an enormous amount of heat, acting like a thermal battery that takes time to drain. Within about a week, average surface temperatures would likely drop below freezing across most of the planet, and within a year, the oceans would begin forming a layer of surface ice, insulating the liquid water underneath, much like a frozen lake in winter protects the water beneath its surface from the coldest air above it. Here's the twist most people never consider. Total darkness doesn't mean total extinction. Photosynthesis would collapse almost immediately, and most plant and animal life dependent on sunlight would die within weeks to months, as food chains built on plants and algae unravel from the bottom up. But deep in the ocean, entire ecosystems already don't depend on the sun at all. Around hydrothermal vents on the ocean floor, bacteria convert chemicals from Earth's own internal heat into energy, a process called chemosynthesis, supporting tube worms, crabs, and shrimp that have never needed sunlight for anything, in ecosystems that have existed unchanged for hundreds of millions of years, long before complex life ever colonized the sunlit surface. That's the edge of what we know. An event that would end nearly all life on Earth's surface within months might barely register to an ecosystem that's been thriving in total darkness this entire time, powered by the planet's own leftover heat instead of a star 93 million miles away. It's a humbling reminder that life on Earth and life dependent on sunlight turned out to be two different categories, and we only discovered the difference by accident when submersibles first reached those vents in the 1970s. So here's the honest answer. The sun disappearing wouldn't be an instant apocalypse. It would unfold in stages. 8 minutes of false calm where nothing seems wrong at all. Then sudden darkness and a planet flung into the void. Then a slow multi-year freeze that ends surface life while leaving pockets of it clinging on in the deep ocean and, eventually, underground, where geothermal heat continues regardless of any star. Earth itself would keep existing for billions of years afterward, drifting alone through interstellar space, a rogue planet with no star left to call its own, no longer anyone's planet to orbit. There's an equally strange question waiting on the opposite end of the size scale, far smaller than a vanishing star but just as poorly understood. What happens deep inside your own body during the near-death experience, and what science actually knows about it? That's a story for another episode in this series, so subscribe if you don't want to miss it. I'll see you at the edge.